The structure of today's session will be a 5 minutes of introduction from myself, a 20 minutes of presentation each from our speaker, Professor Datin Batuka, Dr. Teo Su Huang, who is the founding chief executive of Cancer Research Malaysia, and Mr. Daniel Saifuddin, a PhD candidate from University of Queensland School of Pharmacy. And lastly, a 30 minutes of open discussion and Q&A session. We will pick the questions from the chat session, so please drop your questions. Everyone needs to keep your mic muted during the presentation, but the chat function is always available. You are encouraged to turn on your camera so the session is more interactive, but it's optional choice. During the open discussion and Q&A session, you're allowed to raise your hands to get the permission to unmute your mic to ask questions. With a theme of working in the bioscience field, Malaysia versus overseas, today we'll be exploring the reality of working in a research lab in both Malaysia and overseas. To kick things off, a short introduction of our speaker for today is Prof Teo. Since returning to Malaysia in 2006, Prof Teo research has contributed a lot to the cancer research. She was in charge of more than 100 genetic loci associated with an increased risk of breast cancer that lead to the development of breast risk prediction model for Southeast Asian women. This not only enabled the establishment of the national network of centers to offer genetic counseling service, but also to create the most comprehensive genomics map of Asian breast cancer, the new nurse-led model for modeling the survival of breast cancer patients. For her outstanding work in cancer research, she has won the Top Research Scientist of Malaysia Award in 2014, appointed a Fellow of Academics of Science in 2014, as well as the Dato' Saifuddin Idris Shah Award from HRH Sultan of Selangor in 2018. So let us welcome our speaker of the day, Prof Teo. Without further ado, over to you, Prof Teo.
Thank you very much for the introduction, and thank you very much for the invitation to come and speak to you. And I'm not entirely sure who I'm speaking to. I assume you're all Malaysians and you're somehow involved in science and you're wondering, should I make the move of coming back to Malaysia, or should I really listen to my parents, listen to what everyone else is saying, and believe that there's no credible science that's being conducted in Malaysia, and I should really stay on in whichever country I am, be it in the UK, North America, Australia, New Zealand, etc., stay anywhere else but come back to Malaysia in terms of being a scientist. So what I wanted to do today is, and maybe what I was asked to do today was just to share my story, and hopefully by hearing one person's story, that will spark an interest in coming back to Malaysia. And also, I'll be happy to answer any questions that you might have in terms of what is it like to come back to work in Malaysia. You know, we were asked these questions when we were young, right? Yeah, probably from standard 2, you were already asked, what would you like to be when you grow up? You have to write an essay starting with 50 words, and then by the time you get to secondary school, the essays become longer and longer. What would you like to do when you grow up? When growing up, you know, the reality is I wanted to only be a daughter, a good wife, and a good mother. So for me, this was my life's mission, in a sense, just to be a family person and not do very much more than that. But life turns out very strange in many different ways, and I had many, many opportunities in my life. So I was very privileged to be an ASEAN scholar, and so that took me to Singapore, where I was in Raffles Girls' School, and then in Raffles Junior College, often called the pressure cooker schools because it's the top school in Singapore, and therefore a very stressful environment and so on. But growing up in a middle-income family, I knew that I would never even go to university if I don't have a scholarship. So I was very privileged to win 3 different scholarships, and that would have actually taken my career in very different directions. So I could have become a scientist if I went to Cambridge on a Yayasan Samdawi scholarship. I could have become an economist if I took a Monetary Authority of Singapore scholarship to go to the London School of Economics, or I could have become a air stewardess or management trainee if I took a scholarship to do science at the National University of Singapore. So the reality is I chose Cambridge because it was the most prestigious and was a fully funded scholarship from Yayasan Samdawi. From there, I went on to win the Wellcome Trust PhD prize studentship, to do my PhD also at the University of Cambridge. I was very fortunate to be the top student in my year in the Department of Biochemistry. Completed my PhD in 3 years. And then I won a Royal Society Dorothy Hodgkin Fellowship, where this was a hugely competitive award to do a postdoctoral research in a different group, yet also at the University of Cambridge. So going down this route, academically doing very well, then go to the top university, one of the top universities in the world, winning some of these prestigious awards to do PhDs, and then building my own research career with a research fellowship and building my a track record at the University of Cambridge. Why would I actually want to come back to Malaysia, right? It's a very tangible thing, as in why leave the top place to do research in the world to come back to Malaysia. So I was asked by Tan Sri Tunku Ahmad Yahya. Tunku was the deputy chairman of Saim Davi Berhad, the company that gave me a scholarship to go to the University of Cambridge in the first place. And he called me one day and said, he had been approached by his university, the University of Bristol, and they were doing research on oral cancer. But unfortunately, oral cancer is not very common in the West, and therefore there was very little money available to do this type of research in the UK. But oral cancer was much, much more common in Asia, and oral cancer survival had not changed dramatically. So he asked me, should we be raising money to do something on oral cancer research? And I said, yeah, of course, why not, right? It's a good thing to do, because without research, there'll never be any development. There'll never be any improvement in outcomes for patients. And of course, we need to be able to do research in the cancers that are common in our part of the world. So we set about going to talk to people about, if we raise money in Malaysia, would they want to do the research in Malaysia? So we went to talk to the universities, we went to talk to MACNA, we went to talk to the Ministry of Health, and we asked each one of them, if we raise the money, would you do the research? And they all said, no, because at the moment there's no capacity. We can't do cancer research. It's not our priority. We are working on dengue, we're working on malaria, we're working on, on infectious diseases, and that's our priority. Non-communicable diseases is not our priority. It's the disease of high-income countries, and of course we wouldn't do that work. But Tunku was undeterred, and he was able to get a couple of people to support us. He got, through Tun Mahathir, a donation of 2 million ringgit to set up a laboratory. We spoke to the founder and the late Tan Sri Lim Goto and he gave us 1 million a year for the first 4 years for us to set up. And then we spoke to Petronas, and Petronas said, okay, we'll give you 1 million to set up a research laboratory. So with essentially just 3 million ringgit and 1 million ringgit per year as an operational fund, Tunku said, okay, we're going to do this. We're going to set up a non-profit organization that will do research in cancer. And we're going to make this a world-class institute. I was 28 at that time. So I didn't know anybody in Malaysia, because I left the country when I was 13. I didn't know any of the scientists in Malaysia. I barely even know Malaysia very well. And I don't even have SPM Malay. And here I was trying to figure out, how am I going to set up a research institute and try and make it internationally credible? So a lot of people ask me, why would you give up your career and your trajectory as a fairly reasonable, successful trajectory, right? Royal Society Research Fellowship means that you're on your way to becoming tenured and becoming a junior lecturer in a good university in the UK. Why would you give that up to come back to Malaysia? So the reality is these 3 little words mean a lot to me, because you can. So it's really important that we do things because it is an opportunity that's presented to us. And perhaps we are the only ones that can do that at that particular time. And if we can move that piece along, then perhaps someone can stand on the successes that we have achieved to be able to make more of an impact and to make it easier for the next generation to be able to do what they can. So what did I have to lose? Nothing, pretty much, because if I came back and it didn't succeed, a bit of a loose face, but I would be able to succeed and get another job. But if I was able to make something happen, then what would happen? What is the consequence of that? The consequence of that would be that Malaysia would have an institute that would be doing cancer research. We would be putting Malaysia and Asians on the map for cancer research. And who knows what the future holds if we begin and take that step. And so we began. At the time that we began, everyone called the disease the big C. The reality is today, cancer is still called the big C. So why is it called the big C? We call it the big bad wolf, right? We call it the big C because it's fearful. Because for the majority of individuals, when they're told they have cancer, they only have 3 questions in their mind. Number 1, how much time do I have? Number 2, how much pain will I suffer? And number 3, what will happen to my family? How will I afford it? And so on and so forth. So for most people, cancer equals the death sentence, and we call it the big C because it's something fearful. And we went about setting an organization that would build a future free of the fear of cancer. So that's our vision, that we're going to reverse cancer through research. That basically means that what we want to do is ensure that instead of having 60% of the deaths due to cancer in Asians and only 10% of the research being conducted in Asians, we wanted to make sure that Asians were not left out in the fight against cancer. So that was 20 years ago. And over the last 20 years, we've been making steady progress in doing some things in the fight against cancer. And our focus is really important. So number 1, we're looking at how we can boost the patient's immune system to fight cancers, particularly for the cancers that are common in our part of the world. We've developed a cancer vaccine based on proteins that are overexpressed within a tumor cell. And we are just completing the preclinical studies. And if everything goes well, we'll start phase 1 clinical trials, hopefully by the beginning of next year. This is a very significant thing because we're going from zero. My first job was carrying a little canister, not very different from this container. Sorry, you can't see it. Not very different from this container, but I would carry this to an operating theater to collect tissue samples from surgeons operating on oral cancer patients and collect that to go back to the laboratory, cut it into little pieces and grow cancer cell lines. And from growing cancer cell lines, we took the first microarray experiments to understand what proteins were overexpressed. We then laboriously worked out which ones were driver genes that were important for the cancer development, which ones were needed by the cancer cells for the cancer cells to be able to grow, which ones would make good vaccine targets. And fast forward to today, we now have a vaccine that we're very hopeful, at least in an animal model, it's very, very effective in boosting the animal's immune system to fight against cancer. And if our projections are right, we will be able to increase response to immunotherapy in oral cancer patients from potentially only 20% to over 70%. And all of this was done right here in Malaysia. What else have we done? We put Malaysians on the map in terms of research that is about genes that cause an increased risk to breast cancer. So I put an image here of Angelina Jolie, because Angelina Jolie very famously came out to tell the world that she had had prophylactic mastectomy because she had inherited an altered gene from her mother that caused her to have a very high risk of developing breast or ovarian cancer. But the reality is that of the 50,000 Malaysians who have exactly the same genetic alteration as Angelina Jolie, at the time that we started, less than 50 of them would know their genetic status. Very few individuals knew what were the genes which were involved or implicated in breast cancer risk. And we set out to try and map out not only the rare genes, but also the common variants that are associated with an increased risk to breast cancer. So this work has recently been published in the New England Journal of Medicine, where I was a senior author, as well as in a paper that was published in Nature Communications. And another paper is currently under review, also in Nature Communications, to be able to take forward that work. So this is important because we are putting Malaysians on the map. It's not just about doing research and celebrating Malaysians who are achieving amazing things in laboratories overseas, but this is about Malaysians doing important research right here in Malaysia. A third area where we chose to invest in is in creating genomic maps of Asian breast cancers. So what are genomics? Well, the reality is, in the past, we used to understand what treatment will work for patients by understanding where the cancers are occurring. So if you have breast cancer, we give you one treatment. You have liver cancer, we give you a different treatment, and so on. But we now know that not all patients will respond to the same treatment. And that's because at the microscopic level, they may look similar, but at a genetic level, they're actually significantly different. They're driven by different driver genes. So only by creating a genomic map of understanding the different types of breast cancer in the Asian population are you able to choose the most appropriate treatment that may work for those patients. And that's exactly what we did. At the time that we started this work in 2015, less than 2% of the genomic maps were in Asian patients. Today, because of the genomic maps that were created by Cancer Research Malaysia in collaboration with our partners, 19% of the genomic maps in breast cancers are from Malaysia. And that has enabled us to identify features of Asian breast cancers that are clinically relevant. We launched our first clinical trial testing a particular biomarker in Asian patients to predict response to immunotherapy in July last year. We won a major research grant from a pharma company to take forward a second clinical trial, which will be launched, hopefully, if everything, barring the pandemic and everything else, hopefully it will be launched in Q3 this year. And we are well on our way to be able to identify other biomarkers that predict response to Asian patients. So my story here is really not about me. It's really about the purpose that an organization exists to try and put Malaysia on the map. And to be able to do this, we need scientists. We need Malaysians to believe that this is possible to do, that we need to do this because we can, and because there's a much bigger cause that we need to serve. So the reality is that 70% of cancer deaths will be in poor income or low income countries. 70% of cancer deaths. And within the next 15 years, it will go to 85% of cancer deaths will occur in low and middle income countries. Survival in Malaysia is one of the worst in Asia, and there's a huge need to have more scientists come back to Malaysia to ensure that we can improve the survival of the disease in this part of the world. So for me, I'm going to stop there and really, hopefully, give you some food for thought in terms of why it is that I have no regret in coming back from the University of Cambridge. In fact, I feel very, very privileged to have been given the opportunity to train at the University of Cambridge and then to bring back my expertise, bring back the links that I've had to be able to grow a research team right here in Malaysia. I would really very much encourage all of you to really think about coming back to Malaysia because this is ultimately home. For me, my husband, myself, my two kids, my family, we're all incredibly privileged to have come back to Malaysia. This is where home is. This is where we belong. And this is where my children have grown up knowing 4 grandparents and being very close to them. This is where we wake up and it's sunny instead of having gray skies in Cambridge. This is where we can go to a mamak store with our friends. But more importantly, this is where we can do the type of science that translates to clinical practice. Because the reality is one of the motivators and major reasons why I chose to come back is because I felt that in Cambridge, science was all about me. Science was all about me. So I was pursuing the best possible research publications, the best possible fellowship, the best possible tenure track position, and so on. It was always on a competition to see what I could put in my CV, which publication I could chase, and so on and so forth. Because that's the life of a scientist, right? You're chasing publications and tenure and research grants. But coming back to Malaysia has been very different. Yes, I'm still chasing research publications, and we're delighted, of course, to have been able to publish very high impact papers. Nature Genetics, Nature Communications, New England, they're all really high impact publications, and we're leading some of these, either as first authors or senior authors. And this is a very significant milestone of credibility for a research organization and for scientists. But much beyond that, it's been about the opportunity to set up something different, where I've been able to use my voice as a scientist to change things, where I've been able to identify problems at a macro level, and because of the systematic way in which scientists talk about them, we're able to structure policy discussions that can change the outcome of what's happening in our own country. So I would say that through my interaction, not just as a scientist, but at the Academy of Sciences, being able to influence committees, at the Ministry of Health, being able to sit on committees and influence policy, being at committee levels at the Ministry of Science or the Ministry of Higher Education, where I can help to look at what is research policy, how can we better support young scientists, how can we better support young leaders that are building their own careers. I think it's been an incredibly fulfilling journey for me to come back to Malaysia, and I can't think of a better reason. I can't think of any reason why it would have been better for me to have stayed on in Cambridge. So I know that's a very biased view. It's a very one-sided view of considering whether to stay on overseas or to come back to Malaysia. But for me, it's absolutely 100% that I've been much happier coming back to Malaysia, and I have absolutely no regrets. Good luck as you make the decision for yourself. As always, I'll be happy to take any questions that you might have. But I'm going to stop here and let you get on with the rest of the program.
Thank you, Prof Teo, for the amazing section. So let me introduce our second speaker of the day, Mr. Daniel, who is currently working on his PhD research project titled Synthesis of Novel Aploid Peptide for Allosteric Modulation. He has worked in multiple research projects, including drug delivery system, formulation, and drug design in multiple labs during his university life. Upon graduation, he worked as a science communicator in Tech Dome, Penang, and a Federal Fellow within the Ministry of Human Resources in 2019. If he is not cooking up new peptide in the lab or explaining about the self to the public, he will probably be synthesizing a delicious meal in the kitchen. So let us welcome our second speaker, Mr. Daniel. Over to you, Mr. Daniel.
Oh, thank you. Thank you, Jonathan. And very inspiring talk from Prof Teo. I really feel inspired as well to come back to Malaysia. A very warm welcome to everyone. So my name is Daniel. I like to just give a brief overview and basically a story of my adventure while I did my undergrad overseas, and also the story that I had when I actually came back to Malaysia, and also managed to do multiple jobs in both Malaysia and Australia. And so let's get on with the presentation. So a brief introduction about me. I'm actually a biomedical science honors graduate like most of everyone. I'm actually currently working on a PhD project to develop novel opioid painkillers to reduce opioid addiction, which is a major problem, especially in countries like the US, Australia, where opioids are being transcribed by many doctors and sometimes have been abused. So I've worked both in Malaysia and in Australia throughout my undergrad and also after graduation. So I'll walk you through my adventures that I have done throughout this whole time, and hope that this also gives a brief message about how everyone is going through as an undergrad student and what kind of possibilities that you can get after you graduate or even while you're doing your undergraduate studies. So basically now I'm working on opioids, peptides like over here. This is leu and enkephalin, and it is known to be non-addictive. And this is why we want to modify it further to actually make it much more stable. So I like to actually start the talk by actually asking, what is everyone studying? So we can see a lot of people doing pharmacology, but mainly biomedical science. Pharmaceutical technology, interesting. PhD in plant virus, that's good. Pharmacy, life sciences, biomed, genetics. Yep. Wow. That's a very good response. Thank you, everyone. So let's get on back to, let's just give it another few more seconds to see if any more new responses. But yes, mainly everyone is part of the biomedical science point of view. Same for me. So let's get back onto the slide. So another question, just brief overview of just getting to know everyone so that we can tailor, and I can tailor my talk to and advice to everyone as well. So what year of education are you in? So I can see a lot of people from year 3, and there's also some in PhDs and masters. That's nice. All right, so I'll just share the results real quick. Good, we can see that mostly everyone is in their late stage of their studies, and that's still a good place to be in, actually. I recommend that. And so basically what I'll talk about is, so university is basically a place for skill and for self and actually skill development. So I'll just use a different kind of term where we actually have like mage and also like lance and also like swordsman. And then from there, we actually become much more improved version of ourselves in university, whereby you can have better skills, better magic in a way, and also maybe even ride dragons. But essentially what the message I want to give across is that in the university is where you start as a novice and slowly climb yourself up to proficiency, mastery, and then practical wisdom. So this is basically the adventure that I had to go through. So when I started in first year, what we learned was like the basic physiology and some cell biology and genetics, where we were trained into the basic stuff. And then we actually were allowed to actually go and specialize and also subspecialize. And throughout the whole time, we actually learn a lot of different concepts. So this is not an extensive list of the biomedical science field, but what we can essentially see that the biomedical science field is just very, very vast and wide. And there are so many different fields to go into. And the good thing as well is that they are all interlinked. I'm sorry if the slide may not show that they're interlinked, but if you can see that each and every field at the end is actually more or less interlinked. And then we also develop more skills such as like human trial and testing, ethics, applications, so an animal research and the different animal models starting from the Drosophila fly all the way up to primates, but mainly we focus on mice. And then with in vitro and lab in vitro skills where we actually test for preclinical trials, and also some who may be lucky to actually go into courses where there are bioinformatics, where we can actually do in silico studies. So basically design the drugs before we even put it into the lab. But what the message I wish to put across is that there are so many skills that we can learn in the biomedical science field. It's a matter of picking and choosing what you wish to do and what the industry and future jobs that you can get into. And sometimes I will also explain a little bit more about the soft skills that we learn in the biomedical science field, especially while I was also in the undergrad. And these skills are also applicable once we go into the job, and it may not even just be lab-based, but I'll explore further. So now just a second question and more of an open-ended question for everyone. I actually like to ask, what kind of jobs can the biomedical science or even science degree bring you? So it's the same Menti room. I will just change it very quickly. Oops. So now the next question is, what would a job you will land? Oh, forensics, that's a very interesting choice. Anything else? Social work, forensics, allied health professions. Yes, that's a medical lab technologist is a famous career choice after a biomedical science degree. Anything else? Immunology. Woof. Yep, there you go. Consultant, lecturers, research scientists. Yep. Science writer. That's good. Science communication. Yep. Lecturer, cell biology, lab setting, science writer, allied forensics. We'll give it another 10 more seconds just to sum everything up. One. But yes, mainly we can also see the first thing smack bang in the middle, research. But there are still so many different types of jobs that we can get from a biomedical science degree. And I will explain a little bit more about how I've what I've gone through. Am I still good with that? All right. So a little bit about my university days. So I started off as like everyone else, first year undergrad in the packed lab, and then tutors who are like what, where one tutor teaches like about 10 students and would often have a lot of questions. But what happened was also that I've started to learn a lot of lab skills from here. So like genetic characterization, PCR, and all of that. And these are the skills that I realized would actually be applicable later on in my degree. And at the same time, well, as a poor uni student, I also worked part-time, whereby I was actually, I'll admittedly say that I was being underpaid, whereby I sell ice cream in a touristy spot. But then later on also I did some co-curricular activities where I actually started to join the committee of the UQ Malaysian Student Association, and then also going up to president. So during my time in university, there were a lot of research opportunities. So like our university had a summer research program, and then also we have courses that would push us to do research in the lab, and then also finally honors. So I'll go through one by one about the different research projects that I go through and the experience I got. So I started off as a summer research scholar, where I actually was tasked to actually develop oral drug delivery system to deliver peptides and proteins via liposomes. So liposomes are basically similar to a cell membrane, where there's a phospholipid bilayer, a hydrophilic head, and a hydrophilic interior, and a hydrophobic tail. So that helps with the peptides where it can fold, and where the hydrophobic regions are actually in the hydrophobic side, and then the hydrophilic side where the water soluble ones can be encapsulated. And then we actually start to protect the layer by adding multiple layers. So this was actually me when I was much younger. I actually had a neck. But yes, we actually, so from here, we actually start to develop my skills where I learn about release studies and also how to actually make sure our nanocarriers are more stable and such. And so that also led me to actually present into more conferences. And so then the next research opportunity I got was with my current co-supervisor, Dr. Harry Parek. So I actually met him through one of my lectures. And I just talked to him about, since you also do drug delivery systems, I also work with this. And he actually allowed me to work in his lab, which also had more industry research focus. And this is where we actually look into mucosal delivery of soluble gels, where it's a solution in room temperature and a gel once it hits body temperature. So my task at that time was to compare different on the market nasal sprays, and we've created and validated methods of different spray profiles, and also we start to work on these like nasal spray delivery system. So we wanted to actually deliver things from nose to brain. So we actually had created this video where once we spray it, it hits up the nose and slowly disperse it into the brain. So these are some cool research that we can perform. And then also, this is where I start to expand slightly further away from pharmacology, but it's still related in the pharmaceutical science point of view. So there is the rheometer, which actually did help us measure the viscosity of our soluble gels. We have the Franz diffusion cell in the middle over here. And also below that is the Fourier transfer infrared scanning machine. And the next is HPLC, which is high performance liquid chromatography. So we can actually separate out the carrier and the drug and actually measure out the drug as it's released. So these are the different skills that I picked up throughout my whole time in my undergraduate. And yes, interestingly, some of us, our lab also works with cannabis. So we actually managed to get hold of a cannabis analyzer from Shimatsu. So basically from here, you can see that we actually can tailor our own skill tree. So we can have a degree and then we can actually put a major in our skill set, and basically more or less like a profile of yourself. And this is especially useful when you actually put it to LinkedIn, where employers will actually hone in on certain keywords. And this is more likely where you can actually be spotted on LinkedIn. And so what happened was when I graduated, I asked the big question, what's next? So basically, I think this was where everyone will hit this crossroad where they're not sure of where to go. So Malaysia or overseas, the main theme of this topic. So I created a choice table more or less, whereby I actually put in like four factors that I determine which I should go back to Malaysia or Australia. So I started with myself, like what are my aspirations and what do I want to do with my life? And so I said, if I'm in Malaysia, I wish to actually improve the scientific research in Malaysia, as I've seen how much development that we get from working in Australia and hopefully bringing the research culture into Malaysia. Then I'll continue through Malaysia. So in Malaysia, yes, there is a pro that I'm closer to home and also family and cheaper cost of living. But the con is that I'm not too sure whether I have room to expand in research. And I have to restart my whole networking point of view where I have to actually meet people, and this is where I'm not too sure whether I can get a job. And the good thing about Malaysia is that yes, Malaysia will welcome everyone back home. But the question is, I had that big question in mind. What about my job prospects? They could be less science related jobs and it could be harder to find. While in Australia, as we can see that, yeah, I can expand my skills and network, create cures that current medicine cannot perform. But at the same time, the cons over here is that I'm very far away from family, expensive cost of living, and the main gaping problem that I had when I was in Australia, and this is where everyone can relate when they're overseas. Most countries allow a short-term visa only upon graduation, and then after that, it is not too. The future is still unsure, where you're not sure whether will you still stay in Australia or overseas, or even get a PR. And so this actually create another big problem in job prospects, whereby most companies and jobs require a longer term visa and also work rights, because the company would train you for 1 year, but after that, for 1 year you work, and then you have to leave. They feel like that would be a bad return of investment. And so most of the time they won't take international students. But if you manage to land through a job through your networks, that's great. But basically, this is just my own personal choice table that I look and assess myself with my current situation. It could be different for everyone else, but it's a good way of rehoning back your focus. And so basically my decision, let's go home, Penang specifically. So my first job, I actually managed to get a job as a science communicator in Tech Dome Penang. So Tech Dome Penang is a science center that is based in Penang, and it's the first science center in Penang. And so my job scope was to actually expand the workshop uh, current list and also new exhibits. And also, I also my day-to-day job would be to conduct scientific workshops for children which have been established. So we had a lot of like soap making workshops, but my main focus at that time was creating microscopy workshops for children. So this is actually a piece of meat that we stain it with methylene blue, some onion root cell, and then also like biological samples such as hair, and then also some tissue. So at the same time, I was tasked to actually work on a Hari Raya theme workshop, which then I said, oh, in Hari Raya, there's all these oil lamps, but it's very dangerous. And so I thought of creating a safer solution, candles. And one funny thing that I learned through formulation is that you can actually have multiple layers and also multiple combinations. So I got creative and said, all right, why not have a candle clock where each layer has a different color and each color and layer have a different scent. So for each time we actually, like for 2 hours it passed, you have this scent, another scent, and then the last 6 to 8 hours, another scent. And it was a very cool workshop that I managed to actually use my creativity. And this was surprisingly well with the science center, because they really like that creative ideas and they value the external like the output from a new view mindset. So then the next, I was actually offered to work under the Ministry of Human Resource as a Perdana Fellow. That is more or less an intern within the minister's office. And this is actually managed under the Ministry of Youth and Sports. And everyone can apply. And I managed to get the position. And so then this is where I actually work into the minister's office, where I provide current feedback on current and ongoing labor issues. This is where my experience of working as a worker outside in a part-time job, it actually is similar, it's a similar reflection to how a foreign worker works in Malaysia. And so these kind of experience are always translatable. And the good thing also is that in biomedical science, we always have to do a lot of research, churn through a lot of journal articles. So this kind of information and data collection help a lot with the ministry. So we've actually like tried to put in our opinions here and there. These are, and also the next one is commercialization. So with our lab that works with a lot of commercialization, I have some background about how can we bring items or like research developed within technical vocational research institutes into the market. So this is like one of the few products that are on the market. So all in all, what I want to put out is that the skills that you learn in a degree can be applicable into multiple ways. And at the same time, you are not really stuck. If you're doing a biomedical science degree, you can see that there's so many different other jobs that you can do. And it's just a matter of how you develop. So at the end of the day, at the end of that year, I actually got a PhD offer and scholarship to come back to Australia. So I told myself, yes, why not? Grab the opportunity for now. So my current PhD project is to becomes more interesting, where it's back into my main focus, where I wish to go into drug discovery. And so this is where we work on peptides and synthesis. So this actually comes back to the main question that goes on with everyone's mind. Malaysia or overseas, and can I get a related job in Malaysia? Doesn't matter. This is what I would say. It is actually what you do with your current situation. So it is possible to get a science-related job, but I would say it's harder to find, and also the opportunities may be limited. But if you look hard enough, you will actually find there are some industries and research labs, such as Cancer Research Malaysia, and also like and many other drug companies who also wish to do research. So in the end, my main answer for this is tepuk dada tanya selera. Ask yourself, what do you really want to do in life? And as the wise Uncle Iro also say, you need to start asking the questions of you ask the big questions. Who are you and what do you want? So, and this also comes back to, if you actually look far in the future, it also doesn't matter, because if I work overseas and I wish to come back to Malaysia, Malaysia has programs for us to return, and there are a lot of benefits where you can have some tax rebates, can bring in a car and possessions, as long as, and by being an expert, you help contribute back to Malaysia. And at the same time, well, for specifically for Australia, if you develop your skills in Malaysia and you feel like, yes, I wish to expand my knowledge and also my skills, I want to go to migrate to another country, there are visas that are available for you to actually go into, such as the Global Talent Visa Program in Australia. So you can do some research into the countries where you wish to go. And in a way, I would say the world is still your oyster. So in the end of the day, it's just asking about coming back to the big question. Ask yourself, what do you really want? And so that's the end of my talk. I like to just acknowledge all of the people that I've gone through, like my team in Tech Dome Penang, Perdana Fellows, and also my lab members that we've worked on and currently working with. So yes, thank you all. And that's all for my talk. Thank you so much. And I hope this has inspired everyone. I will take in questions in the discussion forum after this. Thank you very much.
All right. Thank you, Mr. Daniel, for your sharing. I very inspired from both of the speaker. Audience will feel the same too. So now let us start with our Q&A session. First question from Shakil. Because did not mention which speaker, so I will just open to both speaker. So the first question is, how has the COVID-19 pandemic affect the speaker research or day-to-day job? What are the main differences between before and during and after the pandemic?
Maybe the speaker could answer the first question first. So maybe Prof Teo, would you want to go first?
So I think the pandemic has affected all of us, primarily in terms of funding. So the funding internationally for research has actually shifted dramatically as a consequence of the pandemic. So investments in non-communicable diseases has dropped dramatically. And this is going to really have a knock-on effect on not just last year and this year, but considerably for the next 3 to 5 years, that's actually going to be a serious impact. But on a more practical level, of course, the closures have affected our laboratory itself. So it's been, at one point we had lots of animals that needed and experiments that were terminated halfway. Experiments which took us 9 months to set up. We had to have animals which were sacrificed because we couldn't get into the laboratory, because we had roadblocks and so on and so forth, right? But those are short-term practical considerations. But more than that, it was also about our research studies. So many of our research studies are based in the hospitals, and because patients were reluctant to go to the hospitals, particularly for our cancer prevention trial, our recruitment for those really suffered as a consequence. And some of the clinical trials have a severe impact because the services were shifting towards more urgent priorities, particularly in taking care of COVID-related patients. So the knock-on effects, I think, on the short term are very much on recruitment into research studies and delays in our experiments. But the things that I think we're more worried about would be the midterm effect in terms of funding and what implications that might have on research in anything other than the other C or COVID. In terms of the second question, industry-related experience, yes. I suppose it really depends on what type of industry you're talking about. So I'm a consultant for a number of pharmaceutical companies. So because we do a lot of work, I tend to serve as a key opinion leader and speaker on the speaker bureau for a number of pharma companies. And there is a lot of need for that in the Malaysian context. And so you could climb up the regional opportunities much faster in Asia than you would do if you were the equivalent in the UK. Because in the UK, there's just a much bigger network of experts. So they go to everybody else before they come to you. But because you're a bigger fish in a smaller pond, I guess there are more opportunities for consultancies at that level. But in terms of the diversity of industry in Malaysia, in the biotech sector, of course, it's a lot less than what it would be in Silicon Valley or in Boston, Massachusetts, as well as in the UK or even in Europe. It's purely because of funding and the appetite for risk. So the entrepreneurial culture and the funding for setting up companies is much more difficult. But this is an area of change and investment. So recently I've been in conversation with Kazana and others. They are really seriously looking at how we might want to invest properly in the biotech sector in order to ensure that biotechnology or biomedical sciences can be not just a research area, but a potential driver for the economy. So there's certainly eyes looking at this area, but still a very early stage, I would say.
I see. So thank you, Prof. Teo, for your answer. Mr. Daniel, may I know how the COVID-19 pandemic has affect your research or your job?
Yep. So I'm also currently also reading the questions, and yes, I'll start with question 1. So for COVID-19, initially when I actually came to Australia, it was actually the height of COVID actually. So most of our labs were actually locked down unless our labs have industry related projects and industry demands. And so my lab was actually somewhat involved with industry. So most of the postdocs are still coming into work. Well, for us PhD students, we weren't advised to come in until like the cases were eased down slowly. So after like in about 1 or 2 months, when in Australia, I'm very grateful that we have very few cases. So most of our work kick-started back again, and then we managed to continue our research like normal. The only few hiccups that we've noticed is that there's a lot of shortage on plasticware and also gloves. So these are the few things that we had to consider, and either um, trying to find sources where they may be able to stock like pipette tips and also Eppendorf tubes. And there was one time we actually had to wait for 3 months for a bag of Eppendorf tubes, and it's just funny for that time. Then the second question. So yes, there is a lot on academia and government and policy making, but our lab is just in a good position where we actually also have industry related projects. So I'll just give a brief overview in how an academic lab also have industry projects and slight insight of how industry works. So in industry, they would want a product at the end, and this is how like one of our soldier work. We actually have to work in a way, in a streamlined way, that we incorporate the drug, put it into a suitable nasal spray device, and then also test all of these profilings like spray profile, release, and also the the stability of our formulations. And we also have to abide by stringent rules such as the Food Drug Administration, the Therapeutic Goods Association in Australia. So these are the few things that we also have to look into consideration. In Malaysia, and also like most industry labs, they are also still focusing on creating products and what can they do with the lowest cost but the highest return. This is my more or less what I hear and what kind of opinions I hear about industry. And I hope that answers your question. Yeah, thank you, Shakir, for your question. Yeah.
All right, thank you for the answer, Mr. Daniel. So there's a question to Prof Teo from Irina. Prof Teo, could you talk a bit more about how you managed to set up your own research organization? What were some of the struggles in terms of finding like-minded researcher, funding, established connection? Asking since my specialization is not a major research focus in Malaysia.
Thank you for that question. So I would say that setting up a research laboratory anywhere in the world is difficult, but particularly in Malaysia is especially difficult simply because you don't have a lot of experts and you need to start from scratch for a lot of things, right? So how did I set it up? Well, don't give up lah. Everything starts with a single step, right? And then you build along the way. So, when I first started a laboratory in Malaysia, what was my area of expertise? I had done work on genetics. I had done work on transcription factors, chromatin remodeling factors, use yeast as the genetic systems. I had zero expertise in cancer samples, zero expertise in genomics, zero expertise in clinical trials, etc. But I think as a scientist, you learn. And one of the powers of a scientist is you have two things. One, a heck of a lot of curiosity, because you're always curious about why is it like that now? Could it be different? You're a learner, right? You're curious about things and you're a learner. And number two, you have a lot of grit. You never give up. And these two are really important. So you just keep trying and try again. You start here, doesn't work, you try it at something else, and it doesn't work, you try something else. And I think in a sense, it's embedded in the word that we all work on, right? What are we actually doing? We're all searching for something, and we do it over and over again. So we do research. And the reality is we apply that principle to everything in life. So even into setting up a lab, you start somewhere and you go from there. So you might start up a lab with a few techniques and a few members of staff. Then you talk to a lot of people and try and figure out what are new directions that I can go down. How do I make those work? Then you grow a team and see, okay, can I grow that team much bigger? Can I enable more people to be successful? You build your first research paper is really crap and in some small medical journal in a local setting. Then you try and get the interest of more individuals to come on board, build better teams and grow from there. It doesn't happen overnight. But I think if you have the vision, the curiosity and the grit, it can happen, and really doesn't matter where you are, whether you're in Malaysia or somewhere else. You need all of those characteristics in order to be able to succeed.
All right, thank you, Prof Teo. I think that be curious and never give up are important attitude throughout our life. So there is a question to Mr. Daniel from Irina. Did you ever consider working or doing a PhD in other topics, countries, or universities? What helped you make the decision to continue at your current institution?
Yeah, so thank you, Ariana, for the question. I'll start with the second question, which is actually what drive me to actually choose this particular research. It's actually more or less when I have a relative who actually had skin cancer, and she actually was prescribed a lot of different medications, and one of it was, I think, one medication that is a steroid that caused her to actually develop glaucoma. And these kind of drugs that I realized when I was also working in like observing her condition, I noticed that a lot of drugs actually have these side effects. And this is why I wanted to find a research project that has to actually help with side effects from drugs. So initially, I was also going through a lot of different research institutes. Not many actually develop like drugs that take on side effects. So then I've managed to find this lab that works on painkillers, and painkillers are also known to have a lot of side effects. So this is why I chose this particular lab. In terms of another research institute or country, it also did come through my mind, but it comes back to the choice table that I had, where are my networks? Can I actually adapt very quickly in this particular area? And will it be easier for me to work in that particular area? For now, in the choices, and also whether I get a scholarship and offer to work in that place. So from there, I weigh in my odds and I said it's easier for me to come back to UQ, to University of Queensland, to do my PhD. And this is where also all my networks are here, and I'm familiar with the lab that I'm working with. And so this is why I continued in the same path, I mean, in the same university and also research lab. I hope that answers your question, Irina. Thank you very much.
Thank you, Mr. Daniel. There is another question for Prof Teo from Nazim. I think these are questions most of us are quite curious with. What are the major difference between the working environment in Cambridge and Malaysia?
The main difference is, of course, Cambridge is a lot richer. So Cambridge set out to raise £5 billion over a 10-year period for research infrastructure, and they raised it in less than 10 years. They raised it in 5 years or something like that, right? £5 billion. So reality is, infrastructure is much easier, much better at the University of Cambridge. When I was a student, either a PhD student or a postdoc, it used to be one in which whenever I ran out of a restriction enzyme or something that I needed for an experiment, I would go downstairs to the store, tap in my kind of access card, go to the fridge and take what I needed, sign on the book, and then away we go and continue with my experiment, right? It doesn't matter whether it's 10 o'clock at night or 2 o'clock in the morning or whatever, you just go on with science in that way. By contrast, in Malaysia, when you want to plan an experiment, you order a reagent. It takes 6 to 12 weeks for that reagent to arrive. 6 to 12 weeks, not 6 to 12 minutes. It's 6 to 12 weeks. It's a dramatic difference in the ability to do science. Also in Cambridge, I think what I miss the most is not just about the infrastructure and the availability and the funding, etc., but it's also about the brains. The reality is when you're thinking of something, you really want someone to bounce ideas off. You want someone to be able to say, Sue, what are you thinking? That's a stupid idea. Or someone to say, I heard about this idea from so-and-so, a Nobel Prize winner 3 years ago. This is what they did with that idea. And you really want to do that all of the time because, again, research is about that iterative process by which you refine an idea, you learn from others, and you improve on your idea to be able to take it to the next level, right? So, of course, I miss those discussions. And those are the things that I really miss a lot in terms of being able to do the science here in Malaysia. But it's always a trade-off. I think if you're going to go through life looking at what you don't have and then thinking that you would prefer to be there, then you shouldn't come back to Malaysia. You should just stay there. But if you want to come back to Malaysia, then you should need to make the most of what you have. And instead of thinking about what you're missing, think about what you have and what can you do with what you have, right? So if you open your fridge in the UK and you can buy beef really easily, and you can buy broccoli and other vegetables really easily, there's a certain way that you can cook. But if you open your fridge in Malaysia and you always have chai sim and tauge and kway teow, you jolly well know I'm not going to make roast beef, I'm going to make char kway teow. So rather than lamenting what I miss in Malaysia, what I miss in Cambridge, I think my attitude has very much been, sure, what can I leverage through the connections that I have with Cambridge to make my job here in Malaysia much better? But what can I do with the tauge and the sawi and the kway teow here that a Cambridge professor cannot do because they can't get access to it so easily? And I think that's what makes science pleasurable and exciting and fulfilling doing it in Malaysia. So rather than doing a comparison, it's really about making the most of what you have no matter where you are.
Thank you, Prof Teo. I think I finally got my answer that for the questions that I always curious of. There's another question for Prof Teo from Kelvin. Prof Teo, do you think that the research environment in Malaysia is supportive of researchers, both fresh grads and experienced researchers currently in financial, expectative or facilities? If no, how do you think that can be improved to attract more Malaysian talents to come back home?
Actually, it's nobody's job to attract any Malaysian talent to come back. And if you are a Malaysian scientist that's overseas and you're asking yourself, why don't people make it more attractive for me to come back? The answer is you shouldn't be coming back. Because it's not anyone's job to make it attractive for you to come back. If you want to come back, you make it happen, right? Take the ownership to kind of say, why do I want to come back? Rather than saying, why aren't people making it more attractive for me? Why is it up to them to do that? It's not up to them to do that. It's up to us to make the most of what we have. If you happen to make a connection and that person can make an opportunity available for you, then do that. But the Malaysian scientists are really fighting their own battles. They have to survive doing science in Malaysia is not easy. Absolutely not easy. So you're so busy doing that already. You're so busy trying to, just get your research grants, get talented people, train them appropriately, get to the next level, continue to make an impact, continue to survive. You're so busy doing that. Why would you want to have time to make it attractive for talents to come back from overseas? It's really not our job to do that. Sorry, I'm going to be very harsh in that regard, but I really think that people who want to come back, we'll talk to people who may be interested, right? But it's not none of us have the time to make it a priority to attract Malaysians to come back to Malaysia. It has to be your own choice to do so. Sorry, that sounds a bit negative, but sincerely, that's what I feel.
No worries, Prof Teo. So thank you. So there's a question from Razi. Razi did not mention any speaker, so I think I will open to both speakers. Do you think that there's lack of opportunities to be working in academic research in Malaysia compared to in the overseas like in Australia? So a lot of talents are being pushed into industry-related research. Also, what is your opinion on the working culture of research in both countries? Are they different? I think that Mr. Daniel can go first.
Yeah, so thank you for the question, Razi. So what I would say is I wouldn't fully agree that there is a lack of opportunities for academic research. Is that we have to find the opportunities, especially like there are multiple like Facebook groups like Biomedical Science Malaysia, where I do see that it is being posted out. Like there are research assistant positions that are posted out there. Or on the other hand, undergraduates who also ask directly, or is there a job opening for an academic research lab? So I often would just give some advice that it's better to be proactive to find these kind of research, and they are available, but I will also put out that it may not be very attractive, and most of the research ads that I see on the Facebook pages are very are focused towards a research assistant position for about 2-3 months, and then after that encouraged to go into a master's or PhD program. But this is what I have been observing through the Facebook groups. So my opinion on the working cultures in both countries, I would say that in Australia, work-life balance is being pushed more. And while in Malaysia, when I was working in what do you call it, tech dome, sometimes we also do have to work later, and that is just the life of what we have. But there are also times when I was working in Australia that there are crunch times and we work way longer than what we normally work, like until 1 a.m. But this is more or less part of research, and sometimes we have time points that we have to collect at 12 a.m. But I hope that answers the question in terms of research culture. If not, if there are further questions, you can always ask me to further elaborate. Thank you very much, Razi.
All right, thank you, Mr. Daniel. Next, I think Prof Teo can add on for these questions.
So Razi, I think it's an economic thing, right? So if you look at a country like the US, just the National Cancer Institute has a budget of $5 billion US. $5 billion US, yeah. So current exchange rate, okay, let's say for easy reference, it's 4 times, or it's actually 4.5 times, but let's say it's 4 times 5 billion is about 20 million ringgit, right? 20 billion ringgit. The Malaysian budget for research is 2 billion ringgit. 20 billion, 2 billion. And we're not comparing country to country. We're comparing the National Cancer Institute, which is one sliver of a research institute in the National Institutes of Health. So we're not even talking about all of the philanthropy, funding, etc. that's involved. We're just comparing, just one sliver. So the reality is it's an economic one. If you look at a country like Singapore, for example, Singapore has the A-star has a budget of 19 billion Sing dollars. Remember, ours is 2 billion ringgit. Yes, it's 19 billion Sing dollars. So of course, there's a lot less academic research in Malaysia because we simply cannot afford it. We cannot afford basic science research in this country. We do basic science research terribly because we simply cannot afford it, right? So we have to do research that is more translational in nature, but therein lies a problem. How do you do translational research if you don't know the basics? How do you take something to the clinic when you don't own the intellectual property? How do you do applied science and then just create things which are cheap and cheerful, but actually don't really lead to an incremental increase in knowledge? And so the life of the scientists in Malaysia is so much harder because the funding opportunities are so much more limited, and every dollar that we have has to stretch much further. Right? But therein lies the challenge and therein lies the opportunity, because there are always going to be opportunities for what you can do with that. It might be the case that because you have to stretch your dollar, you are less likely to waste. You're more likely to make sure that you endeavor to make the most of what you have. So you go out and look for what is it that I can do that will actually really make a difference. When I was doing my PhD, this is unknown now. You don't do it anymore, right? But at the time, there was this thing called, mutation scanning, right? So if you're trying to determine the function of a gene, and let's say the gene had 100 amino acids, what the US postdocs would do, because they had a lot of money, they would mutate every single amino acid into 3 different combinations and test 300 possible mutants to see which ones had an impact on the biology or the function of that protein. But the scientists in the UK had 10 times less money. So what the scientists in the UK needed to do was to be cleverer about predicting what were the functional domains. What were the amino acids which were more significant? Which ones would we pick to test? And by picking the ones to test, they were equally able to understand the function of the gene. So what I'm trying to say is that if you have a little bit of money, you need to find things that can make a difference in your own country or to solve a particular problem in science that's relevant to the context of what the country is prepared to fund. It doesn't mean that the quality of the science is less good. It just means that the type of science that you do is going to be different. So you should not come back to Malaysia with the attitude that I can do this cutting edge research in the NIH and the NCI. Why won't the Malaysian government support me to do this type of work in Malaysia? Well, if it's successful in the NCI and the NIH, maybe that's the best place to conduct it, because it requires that high infrastructure, that high regular funding, that kind of thought processes that take place with Nobel laureates and so on, and that's the environment in which you will succeed. But maybe the type of science that is needed to succeed here, within the funding environment that's here, within the problem setting that we're trying to solve here, is different. So don't try and create, I think it's really important that, I don't know how many of you have made a pizza from scratch, right? You go to Domino's Pizza in the US, they don't have ikan bilis and sambal on their pizza. But talk to any Malaysian and tell them that the Domino's pizza is wrong or whatever. It's not right. You ultimately you need to make what you can with what you have and use science to solve the problems that are relevant to the country you're trying to do it. Hopefully, Razi, that answers a little bit of your question. I'm not sure that it was entirely relevant, but there you go. Hopefully that gives you some perspective.
All right, thank you, speaker, for the answer. I think it's an amazing answer, and I feel the same too. To wrap up the session, I will take the final questions from Kersing. Is that both of the speakers are required to be vaccinated to work in the lab? Mr. Daniel can go first.
Yeah, so for the researchers in Australia, I have been recently vaccinated and we are more or less encouraged, but they are still going out rolling the vaccine in phases. So it really depends on which lab, like they prioritize labs that work with human samples and also human contact, while labs that are mostly focusing on just pure lab work have a lower priority of getting the COVID vaccine. It just coincidentally, my institute managed to get offered to get the vaccine, so we all take it. But I do highly encourage everyone to take the vaccine once it's available. I hope that answers your question. Thank you.
Prof Teo?
No?
Thank you for the answer. So that's the end of today's webinar. It's a great honor to hear from Prof Teo and Mr. Daniel to share their experience with us today. To all our audience today from all over Malaysia, and perhaps even some of you who may be turning in from overseas, I'm sure you all have an extra sharing for you all. That hope to see you all soon. Goodbye.